Hey pre-cal babies, guess what? Unit 2 is my favorite. I love polynomials. Tra-la-la-la. They're really fun. Anyway, I get overexcited about stuff and I apologize. Okay, so in this video, we're just going to talk about page 1 and we're going to talk about this idea of what the degree of a polynomial is and what it means to us. So a polynomial, of course, is our most common type of algebraic expression, and we do classify them by their degree. So how do we determine what the degree is? Well, we look at the exponential value of our variables. So let's look at this one right here. We've got f of x equals 3x plus 5. Well, it's 3x. X is to the 1 power, so the degree is 1. All right, let's look at f of x equals 4. Well, there's no variable, so guess what? The degree is 0. All right, let's look at f of x equals x squared. Well, obviously, it would be a 2. And then, of course, when we look at this one right here, f of x equals 5x to the third, the degree is 3 because it's x to the third. Now, this is really easy when you just have one term that has a variable. But what we need to do in this next example, we need to look at the largest sum of the exponents in a single term. So I'm going to direct you as to how we find the degree when it's not quite as simple as it was above this. Okay, so here's the deal. The largest sum of exponents in a single term. All right, so this is something else. This is like, here's a note. Pay attention to this. The degree does not have to be in the first term, just so you know. All right, so as we look at this example right here, I want you to notice that in this first term, we've got an exponent of 4 and an exponent of 1. So the degree of that term is 5. And the second term, there's a 3 and there's a 2. It's also 5. The third term, we got a 3 and a 3 here. That's a 6. And the fourth term, of course, has a degree of 4. So what's the degree of the whole polynomial? It's the biggest one. So it is 6. And our leading coefficient, okay, don't let the word leading mislead you. Okay, the leading coefficient is the coefficient contained in the term that's got the degree in it. So my leading coefficient would be -5. So leading is a little misleading because it doesn't have to be the very first term. It can be any of the terms, but the leading coefficient is the coefficient of the term that contains the degree. All right, so moving on from here. So if you will look at this, I wanted you to just try these on your own. If we were in class, I would give you a few minutes and have you do that, and then, and then we'd come back together and talk about it. So, but I wanted to have, give you these for your, teaching purposes. God, I'm just stumbling over my words today. I'm so sorry. Okay, so our leading coefficient. So let's look at this polynomial right here. As you can see, this first term has a degree of 5, this one has a degree of 3, this one a degree of 1, and this one a degree of 0. So my leading coefficient would be the -2, and the degree is 5. My leading coefficient in the next one, I've got x to the third, 6x squared, -x to the 7th, and 7. So obviously, my term that holds my degree is going to be that one with the exponent of 7 because it's the biggest one. So my leading coefficient is 1, my degree is 7. And then, of course, this next function, f of x equals 14. Well, clearly the leading coefficient is 14 because that's all there is, and the degree is 0. So again, we may do this one in class together with a partner. Graph the following with your calculator, sketch each one next to its equation, and write the degree. What do you notice? All right, well, I'm just going to give you kind of an insight here. The degree of this one obviously would be 4. The degree of this one is going to be 7. The degree of this one is 3, and the degree of this one is 6. All right, so I'm going to go ahead and show you. I wonder if I can just get into Desmos real quick and show you what these look like. That's going to take too long. Never mind. All right, so as we look at this, I'm just going to show you what the graphs look like, roughly. They are not pretty. Okay, that graph looks like that. This graph is tricky. It actually looks like that. This graph, also a little tricky. And this little guy, he's really wacko. He looks a little something like this. Okay, now I'm not going to make you graph anything quite that crazy. You are going to have to graph some of these by hand, but it's not horrible. Anyway, the point I want you to get here is I want you to notice some connections. So I want you to look at this degree of 4, and I want you to look at the end behavior here. And then I want you to look at this one, its degree and its end behavior. And then I want you to look down here at this one, look at its degree and its end behavior. And look at this degree and its end behavior. Hopefully you notice that when it's even, when we have an even degree, up, up, even degree, up, up, actually the even just tells you that the end behavior goes in the same direction. Why are both of these up, up? Because my leading coefficient is positive. What? Yeah. So if we'd had a degree of even on both of these and negatives for our leading coefficients, guess what? The end behavior would have been down, down. You're welcome. Okay, so on this one, I've got odd and odd for the degree. This one's got a down, up for its end behavior, but this one's got an up, down. Why is that? Well, because the leading coefficient here is positive, and the leading coefficient here, oops, is negative. Woo woo! I know, you're excited. Try to calm down. Okay, this video's already been too long. Love you, bye.